Hello class, this is Mr. Parsons here. Just want to take a few minutes to talk to you about the Pythagorean Theorem. Alright, so the Pythagorean Theorem, first of all, you want to look at the parts. When we look at a right triangle, first and foremost, we want to look at the parts of a right triangle. So, you know, a right triangle is a triangle that has a 90-degree angle. Any side across from the 90-degree angle, that is your hypotenuse or your C. The other two sides are called your legs. Alright. A and B, and they're interchangeable because it doesn't matter because of the cumulative property, but we need to always make sure we distinguish what our hypotenuse is, which is the longest side of our triangle, and that's represented as C. The Pythagorean theorem states that the sum of our legs squared equals our hypotenuse squared. Or in other words, A squared plus B squared equals C squared. All right. So as long as you're able to determine your hypotenuse, your legs are interchangeable, it doesn't matter. So for example, if I had this as A and this is B, then it still will work because, for example, 4 plus 5 is 9, but 5 plus 4 is also 9. So our legs necessarily isn't as important as correctly identifying the hypotenuse is for our Pythagorean theorem of A squared plus B squared equals C squared. Now, let's put it into practice. We generally use our Pythagorean theorem to find an unknown side. So we just label our sides, and we use the Pythagorean theorem to solve. So for number 1, 2, and 3, our hypotenuse is missing. So we need to find, we're using the Pythagorean theorem to use the value that we're given, which is the legs, to find the hypotenuse. So for number 1, we're going to do 3 squared plus 4 squared equals C squared. So 3 squared is 9. All right, 4 squared is 16. Add those together, you get 25. So 25 equals C squared, but we're trying to find C, not C squared. So to find out the value of C, we got to do the inverse of square, which is the square root. So when we do the square root of 25, we get 5. So our hypotenuse for number 1 is 5. Pause the video real quick. See if you can apply the same approach to numbers 2 and 3. Okay, let's take a look at number 2. All right, we got our legs of 7 and 24. We're trying to find our hypotenuse. So we're going to do 7 squared plus 24 squared equals C squared. 7 squared is 49. 24 squared is 576. You add those two together, you get 625. But that's C squared. We're trying to find C. So we have to do the square root. So we do the square root of 625, we get 25. So 25 will be the hypotenuse for number 2. Now let's look at number 3. All right, our legs 7 and 12, so 7 squared plus 12 squared equals C squared. 7 squared is 49, 12 squared is 144. We add those together, we get 193. Now we got to do the square root of 193. Now 193 is not a perfect square, but it's okay. We just want to round it to the nearest 10th. So we do the square root of 193, we get approximately 13.9. So the hypotenuse here is 13.9 feet. Look at numbers 4 through 6. Now for numbers 4 through 6, a leg and a hypotenuse is given, and we need to find the value of the missing leg. So we still use the Pythagorean theorem, but now we're kind of working in reverse to solve for the leg. So let's look at number 4. We're still doing A squared plus B squared equals C squared, but the hypotenuse is given. So we got 5 squared plus B squared equals 13 squared. So we need to solve for B. All right, so let's square these. 5 squared is 25. 13 squared is 169. Now you got 25 plus B squared equals 169. We need to solve for B, so we got to isolate B. We got to get it by itself. So we need to move 25 to the other side like we would solving an equation. So we need to subtract. 169 minus 25 gives you 144, but that gives you B squared, not B. So we have to do the square root. If we do the square root of 144, you get 12. So the value of the missing leg right here would be 12 inches. Go ahead and pause the video. Try that same approach to see if you can solve for numbers 5 and 6. Okay, let's take a look at number 5. All right, again, the leg of 6 is given and the hypotenuse of 10 is given. We use our Pythagorean theorem. A squared plus 6 squared equals 10 squared. 6 squared is 36 and 10 squared is 100. So our equations will look something like this. A squared plus 36 equals 100. Or if you had 36 plus B squared equals 100, it still would work. All right. We got to solve for a, so we need to move 36 to the other side by subtract. So we subtract 100 minus 36, that gives you 64, but that's the value of a squared. To find a, we got to do the square root. So we do the square root of 64, you get 8. So the length of this leg will be 8 yards. And then for number 6, again, the leg of 6 miles is given. The hypotenuse is 25 miles is given. 24 miles is given, my apologies. So 16 squared plus b squared equals 24 squared. 16 squared is 256. 24 squared is 576. We need to solve for b. So we'll move 256 to the other side. We're going to subtract. 576 minus 256 gives you 320. That's b squared. To find b, we do the square root. It's not a perfect square, but it's okay. We just want to round to the nearest tenth. So we do the square root of 320. That gives us approximately 17.9. So the length of this leg is approximately 17.9 miles. Now let's do some application. A rectangular pool at Andy's gym measures 25 by 50 meters. So if you think about a rectangle, right, 25 by 50, and think about Andy. Andy is trying to swim diagonally across the pool. So if it's a diagonal distance, that's the hypotenuse that we need to find. So we need to utilize the Pythagorean theorem. 25 squared plus 50 squared equals c squared. All right. 25 squared is 625. 50 squared is 2500 equals c squared. We add those two together, you get 3125. But that's c squared. We got to find c. So we do the square root. And we do the square root. It's not a perfect square, but it's okay. We round to the nearest tenth. That gives us approximately 55.9. And so the distance that Andy swam is approximately 55.9 meters diagonally across the pool. So a pole vaulter, so you got a pole, and that pole is resting against the wall. All right, the pole is 17 feet. But when it rests against the wall, all right, think about that as your hypotenuse, 17 feet. And then when it rests against the wall, right, it's 14 feet above the ground. All right, so 14 would be a leg. Your hypotenuse is 17 feet. And then we got to find the distance from the bottom of that pole vault to the wall at the bottom. So we're going to set it up as saying 14b plus b squared equals 17 feet squared. Now we got to find our leg. So 14 squared is 196. 17 squared is 289. We subtract 289 minus 196 gives you 93. And if we do the square root of 93, that gives you approximately 9.6. So the distance from the bottom of the pole to the wall will be approximately 9.6 feet. All right, let's look at this one here. Notice we got 3 squares that's connected together, and inside it forms a right triangle. All right, so it says the area of square 2, which is right here, that's 64. The area of square 3, which is right here, is 36. All right, find the area of square 1. If you notice, this is the hypotenuse. A squared plus b squared equals c squared. Well, they're already squared. 64 and 36 is already squared. Just add them together. If you do 64 plus 36, you get 100. So the area of square 1 is 100. But if I want to find the side length, since the area is given, to find the side length, you do the square root. And if I do the square root of 100, that gives you 10. All right, let's look at b. So if square 1, the area is 25, and square 2, the area is 16. What's the perimeter? So the hypotenuse and a leg is given, so I need to find what the other leg is. So I have a squared plus 16 equals 25. I want to get a by itself, so I subtract. 25 minus 16 is 9. Let's do the square root of 9. That gives you 3. So the side length for square 3 is 3, but I want to find the perimeter, and the perimeter is the distance around the figure. And since it's a square, all sides are the same. So if I do 3 plus 3 plus 3 plus 3, that gives me 12. So the perimeter is 12 units. Let's look at this. The squares form a model of the Pythagorean theorem. Malachi has solved and found the area of the center square to be 527 units. Describe its area and find the correct answer. So think about it. Pythagorean theorem is a squared plus b squared equals c squared. A and b are your legs. C is your hypotenuse. And the hypotenuse is the longest side. Look at your models. If you look at your models, which one would you guess would be the hypotenuse if the hypotenuse is the longest side? That's right. it will be this one right here in the middle. This would represent your hypotenuse. Look at what Malachi did. He did a leg plus the hypotenuse equals another leg. So that's what the error was that he made. He tried to solve for the leg instead of the hypotenuse. It's supposed to be 7 squared plus 24 squared equals x squared, which is 625. And if you did the square root of that, you get 25. So the Pythagorean theorem we use for right triangles. All right, that's a squared plus b squared equals c squared. A and b are your legs. They're interchangeable. C represents your hypotenuse, which is the longest side of your right triangle, which is always across from your right angle, which is your diagonal distance. All right. So I hope this helps with our understanding of the Pythagorean theorem.